This question had been done, right? Which carbon atom have sp2 and sp3 hybridization? We have solved this, right?
I think so.
Yeah, check it in your notes. Please open your notebook and pen.
I forgot my book at school.
Okay. Write it down in any other notebook. Okay, try and tell me the answer. What is the answer? A, B, C, or D?
B.
T, right?
Yes.
Yes, it is correct. C3H6, C3, and H6. 1, 2, 3, 4, 5, 6. Sorry, it is double bond. May I ask Alisha? Yeah, this should be the structure of C3H6, where this carbon atom have 3 sigma bonds. So it is sp2 hybridized. This carbon atom have 3 sigma bond. So it is sp2 hybridized. This carbon atom have 4 sigma bond. So this is sp3 hybridized. Okay, now we are going to cover a topic that is structural isomerism. Okay, so isomerism. Isomers are what? Isomers are compounds which are having same molecular formula. They are having same molecular formula, but they are having different structural formula, different structures. For example, we'll study the isomerism of a compound C3H6. What is the name of C3H6? There are 3 carbon atoms, so the root word is pro. As we have drawn here, this is also C3H6. So this is propene. So what is the displayed formula of propene? Draw it in your notebook. Displayed means you have to display all the bonds, all the carbon atoms and all the hydrogen. So isomers are compounds which are having same molecular formula but different structural formula. Okay, so this is the displayed formula of propene. So what is the definition of structural isomers? That compounds with the same molecular formula but different structural formula are called structural isomers. So for example, the molecular formula propene. One way we can represent propene like this, and one way we can represent it like this in a cyclic form. C3H6. 1, 2, 3, 4, 5, 6. So this is also C3H6 and this is also C3H6, but there is a huge difference between their structures. It is an open chain compound and it is a cyclic compound. So if you are asked to draw the structural isomerism of C3H6, you can draw simple structure and the cyclic structure.
I'm done.
So here we are going to study three types of isomerism. Position isomerism, where there is a difference in the position of double bonds. Functional isomerism, functional group. For example, in one case it may be a ketone, in one case it may be an aldehyde, in one case it may be an ether, but the molecular formula will remain same. And third, we are going to learn about the chain isomerism. Chain isomerism means if one is your straight chain alkane and one is your branched chain alkane.
I'm done.
Okay. So this is first of all we are going to learn about position isomerism. This is an example of position isomerism where there is a shift in the position of the double bond or in the position of your halogen atom. So in position isomerism, it is the location of the functional group that varies in each isomer. Location of functional group, it may be a functional group or a double bond. Example is provided by the compound with the molecular formula C3H6Br2. So there are four isomers of this compound C3H6Br2. You can count in any of the compound. There are three carbon atoms, six hydrogen atoms, and two bromine atoms. In the first case, it is 1,2-dibromo. In the second case, it is 1,3-dibromo. In the third case, it is 1,1-dibromo, and in the fourth case, it is 2,2-dibromo. Right. So in this, we have four isomers of the compound C3H6Br2. If you can make another isomer, so please let me know another isomer if there exists. Because if you make 3,3-dibromo, it will be equal to 1,1-dibromo because counting will start from right hand side. This is exactly the same as this structure if you make 3,3-dibromo. Similarly, 1,2 is made, 2,3 is also done. 2,3 is done or not? Yeah, 2,3 is this only because counting will start from here now. Okay, so these are the four isomers of position. These are the four position isomers of C3H6Br2. Draw it and think and if you can make any other isomer.
I'm done.
Is there any more possibility of attaching bromines?
No, I don't think so.
Yeah, there's no more possibility. Because if you will attach it at 2 and 3 position, for example, this is 1, this is 2, and this is 3. If you will attach it at 2 position and the 3 position, then also it is same as 1 comma 2, because the counting will start from where the functional group is attached. So it is same as 1 comma 2 only. So these are different ways of representing the same molecule because of free rotation about CC single bonds. Okay, that means you have to remember that this molecule is the same as this and it is the same as this. Why? Because there is free rotation. If you rotate the single bond, it will come back to the original structure. So C single bond is possible. CC rotation is possible. Free rotation is possible. But if you have an alkene or alkyne, then free rotation is not possible. In C double bond C or C triple bond C, they are rigid. Here, free rotation is not possible. So these all are my same molecules, because if you see the stereochemistry, if you rotate one bond, then it will come back to the original one. So this is same as this and this is same as this because of free rotation around the CC single bond.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Longest carbon chain. So you could not select 1 and 2 because there is one more carbon atom. It is because I told you that free rotation is possible. If you rotate it, it will come here and bromine will come here. So there are 3 carbon atoms. 1, 2, dibromo and propane. Hello Alicia, welcome to the session. How are you?
Hello, ma'am. I'm okay. How are you?
Yeah, I'm good too. So what we are discussing here, we are discussing the structural isomerism. So you can take a screenshot quickly. This is the displayed formula of C3H6, which is propene. This is your open chain structure. Isomers are compounds which have same molecular formula but different structural formula. You can make the cyclic structure also of C3H6. Okay. So molecular formula is same, but you can draw it differently. Their structures are different. Then we'll study 3 types of structural isomerism: position, functional, and chain isomerism. In position isomerism, this is an example of position isomerism in which your position of double bond or position of functional group is different. For example, 1, 2 dibromo, 1, 3 dibromo. But if you count number of carbon atoms, number of hydrogen, and number of bromine, it comes out to be same. Then this is the these are I told you that here carbon single bond free rotation is possible. but carbon-carbon double bond and triple bond free rotation is not possible. So they are this first structure, second structure, and third structure. They are all same because you can rotate the carbon-carbon single bond. Then we are discussing about the IUPAC, International Union of Pure and Applied Chemistry. Basically, it is a convention for chemical compounds, which is defined by scientists all over the world. Carbon 1 is called METH, carbon 2 is called H. They are on the basis of IUPAC nomenclature. All the rules which I told you how to write the name in, is it because of this IUPAC nomenclature, which is the name which is accepted by all over the world. So what is the name of this compound? You have to first count the number of carbon atoms. There are 3 carbon atoms, so it should be pro. Then you have to see is it double bond, triple bond, or a single bond. It is a single bond, so it is ane, propane. It is alkane, right? Ane means it is alkane. Then you have to see the functional groups. So at first position and second position, your bromine is attached. So you will write 1, 2. Since there are 2 bromines, so you have to write di also. 1, 2, dibromopropane. So it is the name of this compound. Is it clear? If you have any doubt in this, then please let me know in the nomenclature.
No.
Okay.
I'm also done.
Okay. So this is your position isomerism where there is a difference in the position of your functional group. Now here in functional group isomerism, your whole functional group is changed. So there are different functional groups present in there. For example, you will study C3H8O. The molecular formula is same, but with this compound we can draw both an alcohol also and ether also. Alcohol means ROH. This I have already told you in the last class, their general structure. It is ROH. Ether is your ROR. So try to make these structures ROH and ROR from this C3H8O and then count the number of carbon atoms, hydrogen atoms and oxygen atoms. Functional group is different. Here it is alcohol and here it is ether, but the molecular formula is same. So draw it.
Observe.
I'm also done.
So two isomerism we have discussed, position and functional. Next one is chain isomerism. So basically they differ in their structure of carbon skeleton. Butane and methyl propane, they are chain isomers both with the molecular formula C4H10. So I want you to draw the displayed formula of butane and methyl propane. So here in chain isomerism, your longest chain is different. Here we have the chain of 4 carbon atoms and here we have a chain of 3 carbon atoms. But the molecular formula should be C4H10. So draw the displayed formula of butane and methyl propane.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
State the structures of butane and methyl propane. This is butane, where we have 4 carbon atoms, and this is your methyl propane, where your methyl comes out and the branching. So this is the carbon chain of 4 carbon atom, and this is the carbon chain of 3 carbon atom. So this is an example of chain isomerism. Okay, so this is methyl propane. If you have drawn it like this, if you have done it like this, branching at the first position, then it is not correct, because I told you that the longest carbon chain, we have to select longest carbon chain. So it is only the 4 carbon atom. So it is not chain isomerism. The branching should be at the second carbon atom. So that it is 1, 2, and 3 propane, 2 methyl propane. In the IPSC name, you can write 2 methyl propane or methyl propane. It is one and the same thing, because there is only one structure which is made out of this formula.
Why is it not correct if you put it at the first carbon?
Pardon?
Why is it not correct if you put the branching at the first carbon?
If you put the branching in the first carbon, then it is a chain of 4 carbon atoms only. See, just see here. It is CH2, CH2, CH3, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. This one. So this is not correct, because if you name this compound, it is butane only. So there is no chain isomerism here, because you have to number the carbon atom like this: 1, 2, 3, and 4. As I told you in the previous session also, that you have to select the longest carbon chain which is in continuity. So it is also butane. It is also butane. And I told you that it is carbon-carbon single bond free rotation is possible. If you rotate this single bond, it will come here only. So that's why it is not correct. Clear?
Yes.
So there is only one structure of methyl propane. If you put the branching on the third carbon atom, then also it is butane.
I'm done.
So these are your homework questions. Please write it down. You have to draw the displayed formula and name the functional group isomers of C3H6O. You have to make aldehyde and ketone out of this formula C3H6O. And you have to draw the displayed formula and name the structural isomers of C3H7Cl. So you have to make the position of chlorine different at first carbon atom, second, third, respectively.
I'm done.
Okay.
I'm done.
Okay. So what we have covered in today's session, the structural isomers. First of all, what are isomers? Isomers are compounds which have same molecular formula, but they have different structural formula. Okay, so with a given molecular formula, you can make the different structures based on your chain isomerism, position isomerism, and functional isomerism. In position isomerism, only the position of double bond or the position of functional group is different, but functional group is same. You are not changing the functional group in position isomerism. But in the case of functional isomerism, your functional group is changed. For example, we have learned how alcohol and ether can be made by a simple molecular formula. Now you have to practice question number 2 also here, C3H6O. You can make an aldehyde out of this formula. You can make ketone out of this formula, right? Then we discussed about the chain isomerism, where your root chain, okay, the longest parent carbon chain is changed. For example, methyl propane and butane. Molecular formula is same, but the structural formula is different. So in the next class, we will study about the stereoisomerism. So let's wrap up the session here only. Thank you for joining.